Today's lesson is on exponential modeling, percent growth and decay, and compound interest. By the end of today's lesson, you should be able to use the exponential models to solve growth and decay problems and identify all parts of the equations and understand how they affect the outcome. In the worlds of investment and debt, interest is added onto a principal in what is known as compound interest. The percent rate is typically given on a yearly basis, but could be applied more than once a year. This is known as compounding frequency. So P equals the amount initially invested, R is the nominal yearly rate, and N is the number of compounds per year. Now, if N is quarterly, that means it's 12 times a year. If N is, quarterly is 4 times a year. Monthly is 12 times a year. Semi-annually is 2 times a year, and annual is 1 time a year. I apologize for the initial screw up. Thinking ahead. So the rate in this model is referred to as nominal in name only. It's known as this because you effectively earn more than this rate if the compounding period is more than once a year. Because of this, banks refer to this as the effective rate, or the rate you would receive if compounded just once a year. Let's investigate this. So, an investment with a nominal rate of 5% is compounded at different frequencies. Give the effective yearly rate accurate to 2 decimal places for each of the following compounding frequencies. Show your calculations. So I'm just using the part in the parentheses in the exponent. Quarterly. So 1 plus, my rate is 5%, and you can either convert it or keep it with the percent symbol, over N is quarterly, and quarterly means 4, raised to the N, which is 4, and T, which in this case, we're using 1 year. So go ahead, take out your calculator and plug that in. So you get an answer of 1.05094 ... So we're going to 2 decimal places. So that is 1.05, which is a 5%. Oh, sorry. Holy cow. 09. So when we go over 2, we get 1.0509. So that means that we have a 5.09% increase. Make sure you round correctly. That was my mistake. Hopefully that's 2 mistakes so far, so hopefully I'll do better. Monthly. So 1 plus 5%, but monthly means it's compounded 12 times a year to the 12 times 1. So when you plug that in the calculator, you get 1.05116, ... So that would mean we would have 5.12% we would be making over a year. So do you see how if you compound it more frequently, you make more money? Makes sense. I mean, in this case, between quarterly and monthly, it wasn't that much, but any penny matters. So what about daily? So we have 1 plus 5%. Well, how many days are in a year? We're going to assume 365. So 365 times 1. So we get a decimal of 1.05126, ... So move it over 2. So we get a 5.13% on our money in each year. Remember, these represent the effective yearly rate. Okay? This is telling you what the bank is going to give you, but it's compounded more than once a year. That's important for you to know. A lot of vocab in this. All right, let's pause for a second, read example 2. So if it was once a year, we started with $500. and we made 4%. So it's 1 plus 4%, and it says in 10 years. So go ahead, pause, plug that in the calculator. You get $740.12. So part B, if on the other hand the interest was applied 4 times per year, calculate how much the interest would be worth after 10 years of quarterly compounding. Show your calculations. So again, we have a different formula. We're using the one at the top of the paper because we're compounding more than once a year. So 1 plus 4%. It says we're compounding quarterly, so that's 4 times a year. 4 times 10. So go ahead, pause, and find your answer. So you should have gotten 744.43. So be careful because we wouldn't be earning 4% each time it's compounded. You're earning 4% over the year, okay? So you got to be really careful and read, are you compounding it once that year or are you compounding it more than once a year? Got to be sure you're reading. All right, exercise 3. How much would 1,000 invested at a nominal 2% yearly rate compounded monthly be worth in 20 years? So we're using our formula from the other page. So A of t equals 1,000 is our start, 1 plus 2% compounded monthly, so 12 times 12 raised to the 20 years. So go ahead and get that in your calculator. And you should have an answer of $1,491.33, which is choice 2. Now remember, it's money, so they may not tell you how to round, but you can't go more than hundreds to the hundredths. So make sure you're rounding to the nearest cent. So we could compound at smaller and smaller frequency intervals, eventually compounding all moments of time. Thus, we would be letting n approach infinity. Interestingly enough, this gives rise to continuous compounding and the use of the natural base e in the famous continuous compound interest problems. And we have our formula below. A of t equals p times e to the rt. P still stands for your initial or start amount. E is now your base. Instead of 1 plus a percentage, it's just E, which is a button on your calculator, raised to your rate times your time. So exercise 4. Go ahead, pause, and maybe try to give it a start to get that equation down. So we have A of t equals, we started with 350 times E raised to our rate is 2%. Continuously tells us it's the E equation, and we don't know our time. So it asks us in part B, they give us 20 years. So we're finding A of 20 is 350, E 2% times 20. Go ahead and plug that in the calculator, pause the video while you do that, and you should get an answer of $522.14. Part C, algebraically, can't use the calculator, graphically, determine the time it will take for the investment to reach 400. So we know A of t. Our end value is 400. Our start value is still 350 times E raised to the 2%, and we need to find out how much time that takes. So this is an exponential equation, so we need to get it into Venn form, which means we need to divide by 350. So we have 400 over 350 equals E to the 2% t. Now, I want to write it in log form. So, log, my base is E, of 400 over 350 equals 2% t. So when I put in log of base E, be very careful. Let's look at your calculator. So grab your calculator. So we need control 10 to the x to get our log. The E button, if you just want E and not E to the x, then it's in the pi button. And then we have 400 divided by 350. And that gives us 0.1335 ... We're going to divide by 2%. And our answer is 6.676 ... So on our paper, we are putting our answer is t equals 6.67 ... And I'm off the page. And it says to round to the nearest tenth, so that means t equals 6.7. Part D, what is the effective annual rate for this investment? And round to the hundredth. So effective annual rate, we have to find it over 1 year. So we're doing our E, our base, raised to our percent, 2% of 1 year. So again, this was our nominal rate in our problem that they gave us. We're looking for the effective annual rate. So that's what did we make on the money. So E, use your calculator, E to the x button, which is next to the 10 to the x button. Do 2% times 1, and you should get 1.0202 ... And it says to the nearest hundredth. But remember, this is a percent, so we have 2.02 ... percent. So it's 2.02% when rounded correctly. So we're really making 2.02%, but because it's compounded continuously. Okay? All right. Good luck. If you have questions, ask in class.